Hey, all right, we're just getting started here and just kind of thinking about yesterday and how things went with some groups. I think there needs to be a little bit of recall for the unit circle and these values. And then I'm going to throw a sheet at you and then we're going to take it like in stages real quick and hopefully clarify any issues. This was from Mrs. Westberg. What I like about it is kind of the only thing not on it is the graphing, which I spent since last Wednesday kind of rehashing on that up till yesterday, I believe. So, and then at the end of the day, of one of the two reviews given to you, that is a mirror of the written. All right, almost exactly the same, just with uh, numbers shuffled around. And then that leaves tomorrow with kind of a mirror that I made for the multiple choice, which you already got from Friday. Well, at least that one from Friday was about half of, what the multiple choice matching is, really concentrating on the graphing. So the last probably Wednesday, Thursday, Friday really concentrated on graphing, and then yesterday was more about the solving kind of thing. And I think we did a little graphing yesterday too in our worksheet. Okay, so some things that I felt were missing, and actually we're going to take this in stages. I'll pass out the worksheet. The first six questions should literally be done in less than 6 minutes. It actually should be in three. Some of you will be done in less than a minute because you got this down, the unit circle. So the whole thing about this is, you know, really just memorizing quadrant one and then knowing this is coordinate trig, so that in quadrant two, the x's are negative. Quadrant three, both are negative. Quadrant four, the y's are negative. And then remembering the unit circle is always in the format cosine, comma, sine. But the first thing in marking this up is, inverses. We have to remember those restrictions. All right, so I'm going to write them up again. Somebody erased my board. I don't think I did. So whenever you're doing an inverse sine question one more time, we have to be answering questions only from pi over 2 to negative pi over 2. Said that in the wrong direction. So that's why one day on our calendar, and by the way, I grabbed this, the construction of our unit circle was from February 5th. And then when we went into inverses, which I don't know when that was, I'm going to reference the calendar now for those that were struggling yesterday, where we might be able to look at and try to synthesize this here. I colored them in yellow. So where I got this unit circle is from February 5th's notes. All right. And then later, we did a 313 quiz on this, and then more stuff was done with the unit circle. And then I really hammered it on this quiz is, and it's still on your calendar, it's still open. That was the 52 banger. There was a whole bunch of them, but that's when we took every portion of the unit circle and we walked around, filled in all the angle measures, filled in all the coordinates, which are the ones I'm showing you right here. So anyway, it might be worth looking at again. When I looked at it, there were 26 that took it that day. We did do it live in class. And then I was writing on the board trying to, get you any corrections on it. It might be something you look at again. I don't know. Just trying to help those that are really, really struggling on getting these memorized, because that's really all it is. All right. Memorization at this point. Then I said, we actually did this on one quiz, is when we have these restrictions, we have to think of these angle measures not this way, the negative way. So if you have a unit circle out in front of you, this is for when you're doing inverse questions. You're not allowed to say that angle measure. You need to do this. I told you it's silly, but it's just something to memorize. I don't like it, because then when we go to the next section, this is out the door. Then you have to name it from 0 to 2 pi and then name 11 pi over 6 as an answer. But that was presented to you. That was thrown out in front of you. I told you that over and over and over again. We need to lock it in by Thursday. All right, and then not 5 pi over 3. This would be negative pi over 3. You know what? And I'm going to write tan right now too. Tan goes underneath the same rules. Okay, and it's just because of the graph. We don't have time to derive it again. It's already been derived in previous notes. We need to move on. All right, we can't keep spinning our wheels here. All right. And then inverse cosine. It's because of the cosine graph, the cosine kid, blah, 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 blah. But it's also because we hit our negatives in quadrant 2 for cosine. So all of those answers are between 0 and pi when we do that one. All right. And that covers everything. So who never plays in an inverse game? What quadrant is never involved? Everyone say it together. 3, 2, 1, go. 3. I don't know if we want to mark this up and kill it because now we have to erase all this when we go to the next section of actually solving an equation. So right now, the video, I can't pause on WeVideo. Don't get me started with WeVideo. But I'm going to throw the worksheet out at you. By the time I come back, I bet you some of you might be done with half of the first 6 problems. So ready, set, go. Okay, so here it is. The reiteration of yesterday's thing that we started off with that, quite honestly, we don't really went well enough. So that's why we're looking at it. Now, again, one more time though, I should say this on the video, you will not, you cannot have this unit circle up in front of you. So on the test, so at some point it's got to be memorized. So you either look at it or turn it over and then you get an answer, then check. You know, do something so that it gets memorized. Just needs to go a little bit better. Right? Really hoping for a good end before that spring break happens. Okay, so I did say hopefully like some people are already through like 3, 4, 5, 6. All right. So again, one thing I didn't do on these coordinates, remember it's cosine comma sine, and then this was one thing that we did here as well. Sorry, out of order here. Longer, shorter. Oh, I love that. So longer is root 3 over 2 comma a half. That's why the cosine of pi over 6 is root 3 over 2. Sine is 1/2. 45, please. That should be memorized. Root 2 over 2 comma root 2 over 2. And then shorter, longer. So 1/2 for cosine, root 3 over 2 for sine at a pi over 3. One other thing, big problems whenever we saw sine and cosine having 0 or 1 as a value and tangent having 0. By the way, tangent is just this over this all the way through. Just concentrate on the numerators. All right, so that's why tan of 30 or tan of over 6 is root 3 over 3. Tan of 45 is 1. Tan of pi over 3 is root 3 over 1, which is root 3. Why am I ignoring the 2's? Because they cancel. Right? So using this and then seeing what quadrants you're in, naming the appropriate angle measures. And hopefully this goes a little bit better. All right, so jump into this. And then we'll get into the solving and how I look at the unit circle there and what quadrants we need. Okay. All right. So looking at the answers, I'm going to go through these, what you should have done. By the way, 0 over, come on, tell me, 0 over what number? No, that's not okay. 0 over 1. All right. Sorry. Got to like ripping off a Band-Aid. We're at critical moments here. We got to get ready for Thursday. All right. So where do you get 0 for y and x is 1? Well, every time I told you, anytime you see 0 for any of these trig things, you're at 0, 90, 180, or 270. And I hope you know your angle measures in degrees. So it's one of those. Well, 1 comma 0 goes right here. So what's the answer to that, everyone? What radians? 0. Next one, inverse cosine negative a half. What is that, an over 6 or an over 3? 3, 2, 1, go. Over 3. And then cosine's rules, which I had on the previous thing. Whenever it's negative, you have to name a quadrant 2. So what's in quadrant 2? 2 pi over 3. Again, this goes back to this being 3 pi over 3. But go ahead and look at your unit circle and look at the location. All right? This has been the problem. We got to get this figured out fast. All right, inverse sine. Anytime you have a positive, you're in quadrant 1. All right, let's get it over with. So sine of who is root 3 over 2? What's the answer to that? 3, 2, 1, go. It's another over 3, and it's in quadrant 1. That's why these are fast. Anytime you see 1, 0, -1 for sine, cosine, tan, you're on a quadrantal. Okay, so 1 over 1, where's that located? Where are we at? By the way, x has to equal what? And we kind of covered this yesterday too because of the Pythagorean theorem. 0. Where's 0 comma 1 at? Pi over 2. Okay, so that's why these are fast, quick. Move on. All right, well then what does this have to be when y is negative 1 and then x is equal to 0? What do you get for that? So it's negative pi over 2 because you're down 1. Okay, and that's why that is that answer. And then tangent, trying to get this hammered in your head. Which one is this, an over 6 or an over 3? It's one of the two. Which one is it? It's an over 6. I think we said a thing, another little thing I came up with in class. Tan of an over 3 is root 3. Okay, and then we just locked it in there. So tan of an over 6 is root 3 over 3. Whatever tricks we need in order to get this done. Now, how am I supposed to answer tangent questions? With the negative angle measure or not? Yes. So that makes it easy, actually. You don't even have to think, wait, how do I get into quadrant 4? And then go through the whole game. It's just direct right to it. So this was supposed to happen yesterday in that sheet that I gave you to begin class. Bang, bang, bang. All right. Now, I'm going to go back to this. Yes, that's not too bad. Our next section, this is what I told you about this. Not a fan, but this is all gone now. All right. Whenever you're solving a trig equation, these rules are out. We have to look at the directions and see how they're different. So we are no longer in those rules. We are in, and I'm erasing these as well, these angle measures. Now the answer will be 11 pi over 6. Okay. Or depending on if I have to list all answers, what is happening. So I'm only going to do a couple of these and then maybe leave you be. And if you want to pay attention, go. I'm wrong. Sorry. I'm a moron. Let's skip to this section. All right. Because that's the section I was talking about. Shucks. All right. My bad, dogs. Okay. We won't do that. All right. So look at these directions. We'll go to this. Then we'll go back to the secant, cosecant, cotangent, which actually in order, we did do this next. So I'm going to cover my little mistake here. And I might just go through down the odds here. All right. And then leave 23 for last. So number one, we used our CUDA software, but look at this. There are two sets of directions to disseminate the two different types of ways we have to answer this. From 0 to 2 pi, what that means is, going back to the unit circle, why does it say 400? I don't know. But anyway, that means I have to name all answers that are possible. I don't know if this is going to highlight. From 0 to 2 pi. That means these answers are all possible. Okay, the ones that we see on the unit circle. And the whole idea of me trying to hammer in your head for over 6's, this is 12 pi over 6, move backwards to 11 pi over 6 to get in quadrant 4. And then 6 pi over 3. I don't have to write them down again. I hope you got these stuck in your brain. And then here for a particular over 6, this is 6 pi over 6. Jump backwards, jump forwards. All right? Everything is based off of pi and 2 pi, an equivalent fraction. Okay? So now that is this. Okay, but CUDA software, they like throwing these things at you. So how do I get rid of negative 2/5 times? You're going to say it. Say it. Divide, but it's much better to multiply by the reciprocal. Then these cancel, and then I could see what happens better with canceling, I hope, if we can figure out these fractions. So now I get sine of theta equals negative a half. Okay, where does that happen? An over 6 or an over 3? Oh, one more thing that you should put in this is ASTC. Now this is the game. Maybe we shouldn't have that for inverses because those restrictions. But what kind of angle measure it? Over 6 or over 3? There's only two choices. Which one is it? It's an over 6. Everyone should be yelling that because that's the thing I have said a million times in here. Sine of an over 6 is 1/2. So cosine of an over 6 is the root 3 over 2 thing. All right. And that's right here. Sine of an over 6 is 1/2. Cosine of an over 6 is root 3 over 2. And then for over 3's, they switch. This is what's missing. All right. And this is what is causing major tragedies in many quizzes since February 5th. All right. So we got to get this figured out. And then where else is sine negative, or where is sine negative? Which quadrants? Which quadrants? 3 and 4. So what's 3? One more time. If you're at level 1, you got to write down 6 pi over 6. Move forward. What's the answer? 7 pi over 6. So again, this is already a difference. We're naming a quadrant 3 angle measure because of the directions. This is not an inverse question. And then what's the quadrant 4 one? 11 pi over 6. So we'll wait till you answer just to prove we know what we're doing. May not like that, but trying something here. All right, next thing, like I told you, anytime cosine, sine, and even tangent is 0, you're on an axis, man. You're on the x or the y axis. I'm going to use degrees 0, 90, 180, or 270 because we did talk about degrees a little bit, although we should have done more. I will admit that. When doing before we did radians. By the way, 0 over what? I've written this a million times. 1. Okay, so that means x is, and then maybe up there too. I don't know, circx or tix, because this is coordinate trig. So I told you to write that in front of or on top of any quiz, especially for this section here. So this does make sense that then y actually could be 1 or -1 because of the Pythagorean theorem. 1 squared plus 0 squared equals 1 squared. All right. So that's the deal. All right. So where do you get 0, 1? Where's that at on the unit circle? Where's 0, 1? Up here. Then where's 0, -1? 3 pi over 2. So this is the pi over 2, 3 pi over 2. Much different answers because it's a different thing going on. All right. Hoping we have, let me see if we have any factoring here. I guess we didn't. We did have one on our test where we have some GCF factoring. Hopefully that shows up tomorrow, and I think it does on our review, maybe on today's. But this one, we do want to subtract sine squared theta from both sides. And then, darn, I wish something better happened here. This is sine squared of theta then. 2 minus 1 is 1. So as a like term. And then we square root. First thing, when you square root both sides, what happens to 1? By the way, square root of 1 is 1. What do I put in front of it? Plus or minus. Oh, equals. I was wishing it was 1/2 still. And then maybe I'll write that real quick. Like maybe make up something here. So that becomes sine of theta. And then this is plus or minus 1. Sorry, lost my train of thought there. Over 1 plus or minus 1 over. No, not 0 again. It's what? Over 1. Stop saying 0 in the denominator. That's undefined. Got to get that out of our head. Okay. And then this is y over r. Okay. So where do you get? Okay. X is 0, not r. 0, 1 and 0, -1 yet again. Where are we at, everyone? 0, 1 and 0, -1. Same answers. That's where the repetitiveness comes in this stuff. What I was hoping happened was this, throw this down here, then I'll go into the third section. What if you had sine squared of theta equals 1/2? Might be giving away a specific question here. But anyway, don't tell anyone. Square root both sides. What's the square root of 1/2 become? Oh, and I forgot I have to go back to all these questions. Bummer. What does that become? What's the square root of 1/2? What's the square root of 1? 1. What's the square root of 2? Nothing, right? So what does that become? Root. Okay, I'll write it. 1 over root 2. What does that become, everybody? It's on our unit circle a million times. Root 2 over 2. Okay? And I told you over and over again, that's where that comes from because of our triangle 1, 1, root 2. This was in our notes numerous times where we had a 45, 45, 90. Side opposites are 1. Side opposite this because of the Pythagorean theorem is root 2. So the sine of 45 is that 1 over root 2. That becomes root 2 over 2. So got to know these things. Got to know them. All right. So I know I made this up. This is an O and plus or minus. Sine of what kind of angle measure is root 2 over 2 then? Which angle measures? Over what? Over 4. So here is the positive. Here is where they're negative. That is every single over 4. Every single one of them. Okay? So everything's based off of that. Okay? All right. Now, I made a big boo-boo. These are all the answers. I forgot, and sometimes that happens. Only from 0 to 2 pi. So that's how you answer that section. You might want to highlight that. You know, the difference between 0 to 2 pi and writing all solutions. Writing all solutions, 7 pi over 6 and 11 pi over 6, if you remember, are not the same distance away. All right, so I can't name this in one answer. That makes your life easy. To name all answers, all I have to do is tack on that n thing. And the next answer that is equal to this is the one that's this far away, adding 2 pi to it. So 2 pi n, NEZ are popular. N has to be an element of integers. Same thing for 11 pi over 6. X equals 11 pi over 6 plus 2 pi n. And to be honest, I believe I have a cosine. Lies. How far are these away from each other? How far are those away from each other? Yes, you said it right. So it's pi. So this one we can name as one answer and just tie them together with a pi. Okay, because they are pi away from each other, so I can name this in one shot. If I plug in 1 for n, I will get 3 pi over 2. This is why this works. So I'll get rid of that so we don't see that destroyed. Okay, same thing with this one. All right, so we can take that answer twice. And then the reason I kind of did this one in blue, how far are all of these answers away from each other? These are all the over 4s. How far? 90, which is what in radians? Pi over 2. So all you need is one of the answers. Actually, some people have asked me this with asymptotes. It's the same idea with asymptotes. Could I put 3 pi over 4 first? And the answer has to be yes, because it's not wrong. But what you got to make sure is you get the algorithm that creates all the answers. They are all pi over 2 away from each other. All of them. Okay? All right. So again, I had to disseminate the difference between these two. We did this first, and then we did do this next. All right. So it was the order of things, and literally said that, hey, when we do that, we got to get rid of those restrictions. You got to ignore them. Okay. Now this section, we did do this for 2 to 3 days. We talked about secant, cosecant, and cotangent, which, if I look at the unit circle, all they are the flips of these. So secant is related to cosine. What's the flip of 1/2? What's the flip of 1/2, everyone? Okay, then I told you the flip of root 2 over 2 is just root 2 because root 2 over 2 comes from 1 over root 2, which we just looked at yet again with the 45, 45, 90. So the flip of root 2 over 2 is just root 2. Don't blow a brain gasket on that. Make sure you have that memorized. And that's the same for sine of 45 or sine of over 4s. And then the flip of root 3 over 2 is 2 root 3 over 3. All right, so these are the only things you have to do. Write the cosine or the sine down and then flip it for that, for secant and cosecant, if I said those in the correct order. All right, and then what's the flip of 0? What's the flip of 0? That was supposed to be a highlighter. What's the flip of 0? Undefined. All right, and then the flip of 1 is obviously 1. So take a minute to kind of look at these, and then I'll maybe we'll do the odds. So talk with your friends, trying to go through the odds, and then I'll wait for about 2 minutes, and then discuss what you think those answers should be. Okay. You have some negative angle measures, so you do have to go clockwise, finding out what quadrant you're in. So looking at your unit circle, making that happen. Kind of too many over 6s there. I have 3 over 6s in the odds. Oh well, it happens. Do have a nice little pie though. And I did even say, we are supposed to be fast on these, but even if you sketch a real couple quick things down, that's helpful. It still should take no more than 20 seconds to do these. No more. Yeah, I'll give them a minute here. Yeah, we're only at 8:13. Good. Okay, do hear discussion, so I do want to wait. Can't pause the video, so sitting here, dude. Wish there was some elevator music or something. I could sing. Can't think of anything. Do 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 do. Bong pong. Hey, group, raise your hand when you're done. Just the odds, 7 through 15. Just want to get a feel for what's going on. I got some people not doing anything. Teaching in America. We have a test Thursday. Does make me sad, but I'll just leave it alone. Not going to go there today. It's rough. One of my rants, this is what we should have been doing all year long with homework, not having keys open. Try the struggle of getting these answers, thinking. Notes had the unit circle, so maybe at first stage one, using the unit circle to answer these and then weaning yourself off of it, kind of thing. So, no groups done? Checking your phone over there? Nice. Still on his phone. Teaching in America. Good. Done, done, done. Okay, we'll probably go about another 30 seconds. We're at 8:15, 25, 35. So the only last thing I'm going to do is the inequality and do it graphically. So we will talk about graphs. Good. Nice. Done. All right. Good. Awesome. Awesome. Hopefully I don't make a mistake. All right. Good. All right. So I got a lot of hands up there. 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, 0. All right. If we say like level 4 is the highest level, this is where a level 2 student should at least go here. Level 3, level 4, you can probably get the answer just by mentally picturing the unit circle. But secant of pi over 4. So we know cosine is related to that. So the cosine of an over 4 is root 2 over 2. So I should instantly know this is a root 2, hopefully knowing that we have the flip and knowing the flip of root 2 over 2 is 2. And then the next thing is, where does negative 7 pi over 4 land, everybody? Let's see. 3, 2, 1, go. Quadrant what? No, not 2. Not 4. 1. Because it's almost negative 8 pi over 4, which is almost negative 2 pi. So negative 7 pi over 4 requires you go clockwise and land in quadrant 1. So what is the answer then? Positive or negative? That's why we had to do that. Positive. Boom. All right. Cotan of negative pi. Level 2 students, which isn't bad, at least does this. That's where negative pi lands. What is that coordinate, everybody? Negative 1 comma 0. And then what's cotan? Cotan is not tangent y over x. It's x over y. What's negative 1 over 0, everyone? Undies. Okay, so this still did not take a long time. That's my point. So I said those that are level 4 may take 5 seconds. Level 2, 15. And that's still not bad. All right. And it still survives. Okay, we got 7 pi over 6 and 5 pi over 6. Secant, that's cosine's flip. What's cosine of an over 6? 1 half or root 3 over 2? Root 3 over 2. So now we got to know the flip of that, which is 2 root 3 over 3. And then where is 7 pi over 4? What quadrant is that? Okay, look at your unit circle if we still don't know, but what is it? It's quadrant 3. So that's why on this we should still, I can't talk, should have ASTC because secant follows cosine rule. So is that positive or negative? Negative. Okay, good. And then secant, that's crazy. It's the same thing. It's an over 6. This is why there was that repetitiveness, writing ratios over and over and over again. This is why I expected that we're, good on this here. And then where's 5 pi over 6? What quadrant is that? 2. So what does that mean 2 root 3 over 3 is? There you go. All right, where does negative 5 pi over 6 land? What quadrant? Careful on this. Where does negative 5 pi over 6 land? Well, here's negative 6 pi over 6. I heard someone whisper it. You got to go this way, though. So which quadrant am I in? 3. So what's cotangent in quadrant 3? So it is positive. I guess I did that one first. Now, how do I get these over 6s done? We're at level 2. So I don't know what else I could do on this. I have done this before. I've gone back to the triangle. We actually did talk about it as 30 degrees, which is equal to pi over 6. And then we went back to this triangle. I don't know if this is going to help, but this is 1 root 3, 2. All right. Tangent is opposite over adjacent. So this is the reverse, root 3 over 1. Level 4 student does this. Tan of an over 6 is root 3 over 3. So cotan is the other one, root 3. That's how a level 4 or even level 3 student does on this. All right. So that's what we got to take out of that. All right. So it is positive because AST cotan follows the rules of tangents. All right. But it's also because cotangent is x over y. Both x and y are negative in quadrant 3. So negative over a negative is a positive. 5 pi over 6 is still in quadrant 2. So sine is, or cosine always deals with x and r. I lost my pen. Technology. All right. So x is negative and r is positive. So cosine is Kixer. So there's 2 reasons. One, ASTC if you play that game, or number 2, x over r. X is negative in quadrant 2. Again, looking at this is why you learn these, and then it's just symmetry, but then the x's are negative, so you can see the negative x's, which are cosine. But then secant is the flip of that, so it's still negative. All right, and then last but not least, I said I wasn't going to talk about graphing, but when we do an inequality, I think it's the best way to solve an inequality. I wish I could do both of these, but I did want to leave something for you to do and then check your answer at the end. But here's the difference in solving an inequality. I did this 2 ways. If you remember this, if you were here for both days, the first day I really just looked at the unit circle and went around it. All right. And for cosine, I put all the values around for cosine. And then we highlighted the answers. I wish I could pull those notes up real quick. I think it might be right here. There it is. See, remember when I was doing that with the unit circle? If you were here. All right. And then I came back the next day and said, you know what? Probably I was talking with Mr. Wilson about the graphing idea, and it really ties graphing together nicely. Both are nice, though, because I felt we needed this. I think we still need this. This is why I'm doing this today. But the graphing seems to be more efficient and like a little bit faster and a little bit easier to grab the answers. And I do like that. I like efficiency. I think mathematicians should strive for that. I think that's a thing. So here's what we do on this. We actually isolate. You always isolate this. So then you can think about this graphically with the parent function. So all you have to worry about is the parent function of sine, cosine, and tangent. And we're only going to do inequalities with sine, cosine, or tangent right now. That's where we put a stop. When Mrs. Gray sent her a great email about, hey, look at what we're doing here. We need to take a step back. Okay, so now here's how I analyze this. Okay, here we go again. Input, say it. Do we know what that means? All right. So I put this here and here. Here's the cosine kid. I should have asked you, where does the cosine kid start? I guess I didn't ask it yet. High, middle, or low? High. Okay, so we still have to know. We have to know how to graph cosine to graph secant. All right. So I mean, so I still can talk about cosine. And then this is 2 pi. And why are we able to do that? This is the parent function. So I'm able to think about the parent function and its input output values. And then halfway is at pi. That's the low point. And then this is pi over 2. And I'm going to zoom in on this real quick. All right. All the things that we've done, in order to make connections to future stuff. This is why we got to get all that stuff solidified. But all right, so I'm going to go ahead and graph it, and then we got to analyze the question here, and then then it's back to the unit circle. The unit circle. So what am I looking for when it's less than negative a half? So here's negative a half. Where does that happen? Or cosine of who is a half? What kind of angle measure? Over what? Over, not threes. Okay, it is over 3. Sorry, my bad. I was thinking of root 2 over 2. So it's over 3s. All right. And then obviously, look at where we're looking. Here's where this intersects this. So where is this less than? It's all these outputs. Say it again. Input. Those are the out. So I need those inputs. So I have to go back to the unit circle and think, what's the over 3? As long as I know it's an over 3 in quadrant 2, because that's what pi over 2 to pi is. Which one is that? Which one is that? Which is the one? Maybe I do have to go to the unit circle. So which one is in quadrant 2? Because here's pi over 2 and here's pi. That is 2 pi over 3. And then which one's in quadrant 4, which is right here? Okay, which one goes further? Here's 2 pi over 3. And then what's that one? Past pi. All right, I got to write it again. Everyone say what's after 3 pi over 3. 4 pi over 3. Not getting that group response. All right, so those are the inputs that create these outputs. So what's the answer to this inequality? Every input in between 2 pi over 3 and 4 pi over 3. So it kind of referenced both the unit circle and the graph of this in order to answer this question. So it's every single angle measure in between those two. So in these inequalities, you can reduce this down to the parent function graph and then make a comparison input output by highlighting key targets. Okay, so we actually pretty much talked about everything except now graphing, changing periods and all that other identification, which we've done the last 4 days. All right, so really hoping for a strong end here. Our test is Thursday. Forgot to ask, but I think it is going to be 100 points. So we really want to make sure we end well.